Hi, everyone. Thank you for joining me. I hope you had your coffee, or you can have a nice nap now. My name is Adi Shavit. I'm the Chief Science Officer of SWAPP, and I'm getting a lot of questions about what SWAPP is doing. We don't have a very long session now, so I'm just going to talk about some of the pains that SWAPP is trying to remediate, and a little sneak preview into the kind of technologies that we're using. So I took this photo a few days ago at Stonehenge. We actually had a sunny day, so this is a real photo of Stonehenge. And this is an incredible construction project that was finished about 2,500 years ago. And if you can imagine what it takes to transport these giant stones, each one is about 25 tons. And then assembling it, hoisting the stones together, aligning them to some cycle of the Earth and the Sun. This requires a very, very large and ambitious vision. It requires being very creative in solving practical, logistical problems and challenges, and of course, some extreme logistical administration. Now, if we fast forward to today, and we look at the phases of the modern architectural planning, then what we usually see is something that it's been called the McLeamy effort curve, but you can see it's a rough average diagram showing the amount of effort that usually architectural firms need to invest in each of the planning phases. Now, I'm using the American phase names here, but I think they're mostly similar throughout the world. And they're usually called the pre-design or the pre-planning is the first stage. Then you have the schematic design, the design development, construction documents, and the bidding and construction administration. And architects are extremely passionate people. It's a very demanding profession. It requires being both the artistic and creative type, but also some significant formal engineering insights. And this is mostly why they go into studying architecture. So the first phase of the pre-planning is exactly where they get to express their vision. And we've seen some amazing projects done by Foster and Partners and other speakers here today to see all the, whether they're shopping malls or monuments, stadiums, and so on. And then when you actually come to doing the schematic design, you need to have very practical and creative solutions to challenges that come with each of these projects. And again, architects are really well placed and the right people with the right skill set to solve these giant systems of constraints, external constraints from, they might be the developers, the city council, regulations, zoning laws, and many, many other requirements of the customers. But then come the parts for the, well, of course, at the end of the project, they have to follow up on the vision with the construction administration. But if you look at this graph, essentially the y-axis is not just the effort, but it's also the part of what you can think about it as the tedium, where most architecture firms are actually losing money. And that's because creating the construction documents, doing the detailed designs for their projects is the part that requires the largest amount of time from these firms. It's where they actually lose a lot of money. And it's what makes these projects take significantly longer. And this is where SWAPP tries to come in. We're essentially we're automating significant parts of this part of the architectural planning phase. And we also made it our mission to not take away the creativity of architects. So I know there's a lot of FOMO here about AI and about what's going to happen to my day-to-day job. And we've heard people speaking about this since the morning. But SWAPP isn't here to do that. SWAPP is here to make the drudgery go away, to take the tedious parts of the work away and make it significantly more efficient. That means that architecture firms can use that extra time to make their projects better, less repetitive, and of course to take on more projects with the same amount of people, because it's very difficult to find architects these days, and this is something we're hearing from our customers over and over throughout the world. So by giving architects this freedom and freeing them to do the things that they're actually passionate about, this is how I think we can allow them to make an impact. And the way we do that, going from the schematic designs to the construction documents, is using this term called AI. Now, we've all heard about AI, but what is it really? I think it's a very diverse audience here, and some people are more familiar with types of AI. Some people heard about it, it's making all the headlines. And I think in general, if I have to find a definition for artificial intelligence, it's concerned with building systems that simulate intelligent behavior. And it actually encompasses a very wide range of approaches, including those based on logic, search, probabilistic reasoning, and a lot of data-driven approaches. And I want to point out several AI approaches. Some of them are more familiar, perhaps, and some of them you may not have heard them named as such. But this is how, by combining the powers of multiple approaches to AI, this is how SWAPP is able to help automate some of these extremely challenging tasks. So the first type of AI is the one that we read in the headlines. It's called machine learning, and it's a subset of AI, and it learns to make decisions by looking at data. So this is an area which has seen explosive growth recently, and it's actually breaking down a lot of the barriers to previous approaches to whether it's algorithms or in computer vision, in many other types. You've heard about chess playing systems, and we've seen, of course, a lot of generative AI based on these systems, which are very, very much data-driven. So data-driven allows them to be extremely adaptable. They're able to learn from very large data sets and adjust to new information. So very frequently, we don't need to spell out how to do what we want. We just say, OK, look at all these examples. Give me something that's similar or the same for some definition of same. They're also extremely capable at pattern recognition, and they can find and identify hidden patterns and relationships within the data. So again, no need to spell all of these things out. They just emerge from the system, and the system is able to identify these highly correlated patterns within complex and sometimes even unstructured data. That makes them extremely valuable for predicting, for prediction. You know, ChatGPT is based on GPT-4, which is essentially an algorithm for predicting the next token or the next letter or the next word in a sentence. So this is the kind of jumps that we're seeing from previous systems that used to tackle this problem into what I assume many of you have had the experience of playing with ChatGPT. And of course, on the same token, we have the creative aspect, or what's recently been called generative AI, where they can generate very diverse and innovative solutions within the space that's defined by the type of data that they've seen before. And of course, Midjourney and DALL-E, a lot of this picture, of course, I just asked for a futuristic-looking residential building, and Midjourney, this is one of the results that it gave me. And it's an incredible tool for ideation and for visualization and for getting inspiration, because it allows us to map a very, very large space of ideas, much larger than most people actually are able to consume in a very short amount of time. And in general, it's also perfect for inferring things like style, things like conventions, a lot of implicit knowledge. Many architecture firms would give the junior architect a bunch of completed projects and say, OK, this is what the plans for the new building ought to look like. So you go and figure out the type of style, the shapes of the tags that we're using for the windows and the doors, and how we like to present it, the types of print sets, and what kind of panels and the thickness of the walls. So these systems allow us to predict many of these parameters, and we'll see some examples soon. But remember, our architects have another foot in the engineering side. And they need precise and exact and very frequently what I'd call optimal solutions. Of course, optimal is something, it's in the eye of the beholder, and it depends for every project and for every stakeholder in a project. Optimal might mean completely different things, but still, the designs must be compliant with regulations, with zoning laws, with developer requirements, and they must balance building costs and efficiencies and requirements on a per project basis. And these must also be explainable to the client. And I would say that if you look at this building, I showed this to an architect, and I'm sure there are several of you right here. This is a really beautiful picture, but I asked someone, is this buildable? And they said, no, of course it's not buildable. And then he said, yeah, there's no place to put the elevator, or you can't do the structure for this. So, because at the end of the day, this is a bunch of pixels. Midjourney generates pictures. It doesn't generate a fully designed building, and it wasn't planned to do so. And we have to understand that machine learning has its pros and cons, and we must leverage the advantages and see how we can handle some of the disadvantages. Now, if we're looking for optimal solutions, then I want to present the field of mathematical optimization. This is less commonly known, maybe in the general audience, of making systems called, we call them solvers, because you build a very, very large mathematical model. You can think about it as large sets of equations or inequalities, and then we can solve that in with extremely powerful solvers in order to get what are essentially optimal solutions. Now, you might not have heard about this, but I will say this is heavily used in industry, in chip design, in factories and companies to create machine schedules, worker schedules, also scheduling things like flights in airports, and even the NBA games are generated by this type of system because they can guarantee optimality. They can tell you this is there is no better way to optimize your problem. And there might be multiple ways, but this is the best you can do. And of course, since these are mathematical tools, their solutions are exact and they're explainable. If there isn't a solution, you will not get a picture of a person with 4 fingers. The system will just say, no, you have a contradiction within your requirements. I think Jens mentioned this earlier in the context of multiple ISO standards where some of them are conflicting. This system will also tell you where the conflicts are. So we have this precision. They're extremely efficient to solve. It's kind of different than if you know non-parametric systems like genetic algorithms. They don't search for a needle in a haystack, randomly trying out things, but they're actually mathematically targeted to find optimal solutions. And they're extremely fast because they've also made tremendous gains in the last several years. So the way SWAPP approaches things is to actually try to make, to give us on the one side, to use machine learning to understand the requirements of our customers. And we can tailor the type of conventions. We mentioned conventions. We mentioned style. We mentioned what the client expects from our model. So we can use machine learning to flesh out a lot of the details that someone would have had to go and read it from previous examples. And our clients supply us with large amounts of data about previous projects before, as part of the working with our new system, with our system on a new project. On the other hand, we can use mathematical optimization to take those predictions and then guarantee that the solutions are compliant, the solutions are optimal, and they give us the deterministic solutions so that the results are, of course, something that we can explain to the customer and give us a complete solution to go forward with the project. So I think I talked a little kind of hand-wavy, and I do have a few more minutes. So if I had to summarize the technical aspect of SWAPP in a single slide, I think this would be it. I think it's much more boring than some of the other pictures we've seen before, and you might have seen other tasks. But at the end of the day, this is the daily work of the junior architect all across the world. You have some schematic design that came from solving the pre-design and solving the programmatic issues. We have a general layout of each one of the stories in the building, and we need to flesh out the details so that we can have a detailed 3D model of the building, and in addition, a full print set of construction documents and detailed documents for this building. And this is essentially that arrow describes what SWAPP is doing. And of course, these results can be exported to any BIM tool that makes sense for our clients. So both the inputs and the outputs can be done through our system or through additional tools as fits the client. So let's see some examples to give you a little bit more sense about the problem. So if we let's look at the problem of walls. So the original schematic design on the left, which is just some really pretty colorful shapes, don't actually have walls in them. And the customer comes, yeah, this is the general layout of the story, and we have multiple stories, and they're not necessarily all the same in the building. And now we need to flesh out to fill in the gaps between the walls, but I want you to make sure that the walls get the exact thickness that's compliant with the rules, the regulations, the ADA rules, and so on. But also don't make the building larger because it's exactly suited to this particular lot. And then you'll have the city council upon you if you make the building larger. So I want you to somehow insert those walls, the exact walls, between the rooms in such a way that there's also no protrusions in the joints. And so what our wall system actually does, and I kind of try to point out some of these joints, I hope it's clear, is that you can get compliant and context-aware wall types. So the exact wall type between a wet room and a dry room will be whatever the project demands. You're guaranteed that you won't ever get protrusions because it's actually mathematically guaranteed that the walls will be exact. And even though you have T-junctions or all the complicated junctions, it will figure itself. Because we solve for the whole building completely in a single run, the full building will be not only with no protrusion, but also maintain a lot of vertical alignment between structure. So let's say the core, and the balconies, everything is going to be fully aligned. And we can also ensure that, as I said before, we don't touch the envelope. So kind of we're shrinking things in a very clever way. Now, when you ask yourself, how do you actually go about and solve this? Okay, so you showed me what we want to do, and this is exactly what we'd like to do. But how are you going about solving this type of problem? And two questions must be answered. And actually, these questions are going to come up in all of my examples. The first one is, of course, what kind of wall goes where? That is, like I mentioned, the example with the wet room and the dry room, or maybe it's the wall between the elevator shaft and the stairs. And once we know that, how do we actually run some kind of geometry adjustment to make sure that we can fit in these walls while maintaining all of the requirements and constraints that we mentioned before? And traditionally, I mentioned this before, you have a senior architect. He sends the junior architect to look at the previous plans, and she tells her, she makes the plans in the picture. This is Mid-Journey, by the way. You can see they're missing some fingers. But who noticed that before I said? No one, right? So, and the junior architect prepares the plans. They go back and they iterate back and forth and looking at previous examples. So SWAPP kind of does something similar. On the question of what goes where, we have our machine learning AI, which ingests many plans from our customer and understands how our customer designs buildings. And on the side of actually generating the walls for this particular project, we generate a large mathematical model which models the full building and solves it once in order to give an optimal solution. So another example I mentioned is actually the documentation. I've spoken to many of the people here and some of the companies, and architecture firms don't only want to do the modeling of the building. Even once they have the schematic design, they have a nice 3D model. You might call it the digital twin. But their deliverables to their own customers is the full document set. And usually it's eventually generated as PDFs. But usually junior architects, would generate these layouts and decide which tags go on which door and then make sure they don't overlap. And I'm sure many of you architects have had the extreme pleasure of sitting for weeks and fixing these layouts. And then somebody comes and makes a change. They move a wall. They change the position of the door. And you have to go and track down the 250 layouts where this particular door appeared. So SWAPP has put a lot of effort into automating this part of the project as well. And again, we have the same two questions. It's about which sheets does this project require and what kind of annotations, what style of annotations do we want to put on each element and where it goes. And then the second question is, how can we generate these relevant sheets so that they're legible from the start? So once we ask for the sheet, it's already the labels, the dimension lines. Who here enjoys dimension lines? No one? OK, too bad. So the dimension lines and the labels and the tags are guaranteed to be not only in the style of this particular architect or this particular office, but also informative and non-overlapping. So again, the first one is a machine learning problem. The second one is a geometric mathematical optimization, where we actually model the geometry of every view as a mathematical optimization problem. We solve that for the view. I will say that the building, as we saw before, it took about 30 minutes from SD to a full 3D model with a complete set of layouts. And who here has spent hours creating stairs? I see a few hands. I hear that it's architects really enjoy it. Yeah. So again, we're talking to architects. So the way we prioritize the kinds of automations that we're doing, and again, this is just a small part of the things we're doing. I'm running out of time. Is by looking at what architects are actually doing, where they're spending their time, what their biggest pains are. And stairs came up, and we're actually solving. This is the same example I showed before. The original design just had a small room designated as stairs. And of course, we can generate stairs automatically. This takes about 2 seconds. And it also works. This is like an extreme room, extreme building generated especially to stress test the algorithms. But it does work for strangely shaped rooms with varying levels. It ensures compliance with the landings and the in-between landings. And on the way, we'll also let you know if you have internal conflicts, if the room is too small for your requirements, and even if it's too big and you're wasting space. And I will say, as you can see, we'll even fix the connections between the landing and the risers, which I understand the architects hate to do. And if you note, the levels are not the same height. So the reason it's not symmetric, every story here is separate, is different, has a different height, and thus requires a different set of stairs, although the building has the same stair structure for the whole building. So this takes a few seconds to generate and can save weeks of work, especially when changes are made. So this is not just a one-time save within a project lifetime. It actually compounds for every change that comes from the customer. So yeah, these are the connections. So again, here I would say that there is quite minimal machine learning because most humans are relatively consistent with the general guidelines of architecture, but we do generate a mathematical model, again, for the full building to generate the stairs and actually maximize the comfort. So very frequently, there are multiple options for generating the stairs, so we have some kind of freedom, and then we can decide where we want to put that freedom and give us the stair where the width of the stair or the depth of the stair is most convenient. Right, so to summarize, SWAPP enables seamless design revisions, providing a platform that keeps you, that allows you to make changes to your project. At the design phase, of course, you get more time to do your design. You get more time to take on more projects. And everything is fully generated in the 3D model and in your layouts. Of course, it sits in the cloud. It's possible to share and collaborate with others. On the business side, as I said, we're saving time. This is the most painful part. We're saving time. And when you have spare time, you don't need to find that extra architect. You can take on more projects. And you can do, I was speaking to a few folks downstairs earlier, you can actually do the things that are sometimes left out because they're of secondary or tertiary importance. Things like aspects, more general aspects relating to the environment, to the occupant well-being, and these kinds of things which very frequently suffer. And we see that in Israel a lot. We're based in Tel Aviv, and many repeatable neighborhoods. All the buildings look the same because the architecture firms are stressed and the developers have extremely tight deadlines. And we're trying to free up that time for taking on more projects or putting more vision, more of your original creativity into your solutions. Of course, I mentioned, I was talking to some construction folks and they told me, yeah, the results are more consistent. There's no need to generate different types of molds for the concrete because everything can be made to be consistent and less human error. And of course, if you're taking away the drudgery, you're giving your employees, your junior architects, these will be your future senior architects. You're giving them your life balance back. And there's an issue about burnout in the profession. And I think this is, again, one of the things that we're trying to tackle. Give them back the stuff they're passionate about, take away the tediousness. And I think this is the message. I called it make architecture great again. Right, so thank you very much.